So, hi again. This is an extra video to the previous one. This one will be more mathematical. I'll be talking about the math problems that I mentioned in that other video, probability money jobs one, where I talked more or less generally about what are the options, what are the skills necessary, why some of the options are pretty cool in some sense. So now I'm going to dive more into kind of some math example solutions just to give you a better idea of what to expect, and that is not all rocket science. So let's go to, as promised, real mathematical questions from the interviews to some of the companies. Once again, these questions are real questions that I think most of them is what I personally was asked last year. But anyway, going forwards, I think the first thing that you might find a bit surprising is that some of the questions are not even probabilistic, statistic related, anything. They are kind of brain teasers. These are the easiest questions, of course, but still they are there. You need to solve them. Actually, quite many people can't. So here there are two examples. You can think about them right now if you want. If you want to think before I give hints or any solutions, then please pause right now and think. But otherwise, let me jump into them and give either a solution or a hint. So, what's the smallest integer whose digits multiplied together equals to 10,000? So 10,000 is 2 times 2 times 2 times 2 times 5 times 5 times 5 times 5, right? And well, many people could reply something like 2 2 2 2 5 5 5 5 5, right? But that's the wrong answer, because, well, at least you can combine the two 2's into 4, right? And you will get a smaller number because it will have a small amount of digits. Once again, this is just a brain teaser. I just kind of explained why it's even a problem, right? It's not that easy. But still, you do need to do some kind of a greedy algorithm if you know what that is good. But I think the correct answer that you can get to if you understand that, well, first of all, you can't combine 5 with any other digit, so you'll have to keep the 4 5s separately in the number. And then the rest is left to try to combine 2's in some way to get, to be able to get as small number as possible. And I think the correct answer will be this. It's 2 and 8. So you firstly multiply 3 2's because you can't multiply more because you get 16. It's not a digit anymore. So I think that's going to be the answer. And note, not only you need to give the answer, but also give an explanation when you're interviewing clearly, because they want you to think, explain, etc., not just give answers like in many exams, schools, etc. require. So yeah, I was quite loose with explanations because I don't want to spend too much time on the details. Let's go to the next problem. The next problem is, what is the next date whose digits are all unique? So today is 2022, 29, and oh my god, September is 0.9, I think. So this date has quite many repetitions. Just in case, I mean, maybe you're not used to this format. This is month, day, but it clearly doesn't matter. What matters is the date and combination of digits. So yeah, once again, if you want to think, please pause right now, take your time, pause the video for a long time if you want, doesn't matter. Otherwise, I'm going to go into a bit more details. So, first of all, to make, and the next date means that we want the closest date possible to today, that satisfies the property. And so we do want to keep the year is as small as possible. So this is priority number one, kind of. We want to make the year as small as possible. Then we care about the month and then about the day. Once again, it's kind of a greedy algorithm. And so what's the smallest possible year can we have? That is, unique digits and is a year, right? Is a normal number. It is 2031, I think, right? because, well, it's 20311, it's the smallest combination, smallest number that satisfies the property of all digits being different, right? That is after 2022, you can just check. The problem though is that the month and the day will not have any digits, so that you will not be able to for them because you'll only left with digits 4, 5, 6, 7, etc. And that is, well, you can't do anything with this. So it's bad. So we need to maybe think a little bit more. The problem is not as easy as it seems, right? So that's why it's still called the brain teaser, and you need to be careful. Being careful is also quite good in finances, actually. So nice skill that they're checking. But yeah, problem is not much more difficult because you'll quickly realize that both month and the day, they need one of the small digits. A small digit is what I will call 0, 1, 2, 0, 1, 2 basically. Each of them needs one of these digits. There is no way out, right? Otherwise you'll not be able to form a month a day. Actually, they will need each, so we need to have 2 of them. And I think we want to reserve 2 for a year, so it at least starts with 2000, right? So this is not exactly reserved, but if we don't use 2 at all for the year, then the year will be at least 3000. So let's try at least keep it in this, what's it, century, millennia, I think, or whatever, 1000 consecutive years. So then the year will become 2, 3, 4, 5, right? I mean, you can rearrange the digits if you want, but you'll get a bigger year, which is bad. Bad in the sense it will be after 2345. Then the month is the next priority, as I said. So we want to keep month as small as possible and the day as small as possible. So the month can be 0 something and the day can be 1 something, and trying to make it as small as possible, I think we'll get this date. We'll put 6 and 7. So I think that is the answer to this question. Potentially I was wrong, maybe. So you can write it in the comments, but I think that is the answer, I think. And once again, it is important that you go through some kind of an explanation of why this answer. You can't just write it down. You need to explain why. And this is basically a greedy algorithm, not a straightforward greedy algorithm in my opinion. And you do need to present it in the interview. Okay, let's move on to something more probabilistic. So that's also a question that I got at the interview. It was one of the 5 questions at one of the interviews to a pretty big company, not the one that I mentioned before, but still big salary once again, just so you know. And that question is a 3-digit number is called good if its digits are in decreasing order. So something like, something like 530, right? And the question is, what's the probability that a randomly selected 3-digit number will be good? You can pause again, think about it if you want, recall what's the probability if you need it, then solve the problem. Please pause now if you don't want any hints or any solutions. Otherwise, I jump straight into it. And the solution goes like this. So the answer, the answer to the formula to the answer. The question is clearly number of good 3-digit numbers divided by the number of all 3-digit numbers. Yeah, I think that's what everybody knows, right? Note that starting from this point, this question is no longer probabilistic, right? Because we're left with counting the number of some kind of numbers and divided by the number of all 3-digit numbers. So we know what's denominator. It's 900. There are many ways to count it. If you want more details, one more reason to join Quantum. But yeah, in short, this is because 9 times 10 times 10. It's 9 options for the first digit, 0 excluded, times 10 times 10. And the number of all 3-digit numbers is something more interesting, actually. It involves an idea. So the idea is the following. Let me calculate this term here. So how do you calculate the number of good 3-digit numbers? Let's write all the digits in a decreasing order. And then what is left is to understand that every good number is basically defined by 3 digits, right? I mean, don't even need to write this in decreasing order, to be fair, you can just realize it. But once you know which digits are selected, you know which number to write. For example, in this case, 631, right? If you select other digits, well, it will be another number. So yeah, and how many options, how many ways are there to select 3 digits out of 10? Well, if you know what this means, then it's an easy. It's 10, choose 3. For people who don't know, once again, another reason to join Quantum, because it's not that easy. But this number, 10, choose 3, that probably some of you covered maybe in school, I think you should know the formula. Half of you will probably know the explanation, sadly only half, I think I would bet. Yeah, but anyway, this number is equal to 10 times 8 times 7 divided by 3 factorial, which is 3 times 2 times 1. So that is equal to 6, and this is 15, so it's 120, I think. So it's equal to 120, and thus the answer to the question is 120 divided by 900, so equals to, well, 12/90 divided by 3 or 6, so it's 2/15. You can get the approximate percentage, but once you get this, it's okay, it's already good enough, I think. What is more important again is the explanation and how you got to the answer. Okay, and now let's just touch a little bit on a more interesting question, which is the following. You're playing a game in which you roll a fair 6-sided die. If you roll, you get dollars. I think it's not written here, but it should be equal to your roll. Yeah. I mean, so for example, if you roll 3, then you'll get $3. If you roll 6, you'll get $6. So the question is, how much will you pay for this game? And the B, pretend that you can re-roll if you're not satisfied with the first roll, but you must accept the result of the second roll. Now, how much would you pay for this game? So this is a more interesting question, especially because, well, how much would you pay for this game is probably not what you heard, not the type of questions you heard about before. But if you know a little bit more about probability, for example, a thing called mathematical expectation, then this will make more sense to you. So once again, if you want to think, you can pause. Otherwise, yeah, I'll continue and quickly talk about it. So how much would you pay for this game? That's kind of a basic question. Well, my personal opinion, I wouldn't pay anything for such stupid games. But if you want some more mathematical, answer is what I think the company is looking for. They don't want a person who just like comes to, say, an investment or something and says, yeah, I'm just not going to invest anywhere because it's safe. At least I'm not going to, play risky or anything. So what you should know for A and also B, what's the math expectation is. Math expectation. Do you know? If you know, then you know that the expectation of a number that you roll when you roll a first 6-sided die is, so expectation, it's a sign of expectation of a 6-sided die roll is equal to 1 plus 3 plus, 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by 6 equals to 7 equals to 3.5. So if you know what it is, cool, you'll understand this thing. If you don't, then one more reason to join Quantum once again, or just watch something online if you want, just dive in right this second and go into more detail. So maybe you just know it from school, hopefully you do. So $3.5 is your expectation. So if you play many times, then on average you'll be getting $3.5. Thus, well, you don't want to pay more than 3.5 for this game because otherwise on average you'll be losing, so you would want to pay less than 3.5. If you pay 3.5, then, well, you get 0 each time. I don't know, I would respond maybe $3 because, well, you at least pay for whoever you play, so the person will probably agree if that person doesn't know mathematics at all. And you'll be getting $0.50 on average if you play many times. So something like this would be the answer. But the key is knowing this, knowing expectation and understand how to interpret this. For B, the things are more interesting. It requires you to think a bit more. So once again, if you know about expectation, if you understood whatever I said, I think you should try to pause right now and figure out the answer to the B. But if you don't want to, or if you just didn't manage to solve for it, you just want to listen to my voice, then let me continue. So pretend that you can re-roll if you're not satisfied with the first roll, but you must accept the result of the second roll. So the complication here is that you can re-roll. How do you calculate anything in this case? And the answer is, well, when should you re-roll? Like, what is your intuition about this? My intuition says that I would re-roll if I roll 1, 2, or 3, because it is less than math expectation. So when I re-roll the second time, I'm kind of likely, somewhat likely to get more, because on average I get 3.5. So if I roll 1, 2, 3 on the first time, then I should get kind of big chance of getting more next time. And especially if I use the strategy many times, then it is definitely kind of a good explanation for why to re-roll only when 1, 2, 3. But if I roll 4, 5, or 6, then I'm okay. Thus, the expectation will be, if I use this strategy, which is intuitively good, then expectation of my strategy will be with probability probability half, 3 out of 6 cases. When I roll 4, 5, or 6, I will roll 1 of 4, 5, or 6 with equal probability. So I will get expectation equal to 4 plus 5 plus 6 divided by 3. This number is 5. So this is basically 5. Plus in 3 divided by 6, so in half cases, I will re-roll. So I'm basically back to part A, and thus I'm basically back to getting expectation of 3.5. So that is equal to 2.5 plus 1.75, I think, right? Second one is a half of this. Yeah, I think it's correct. So it's equal to 4.25. So that is a mathematical expectation of a number that I get if I use my strategy, which is intuitively good, which is kind of an explanation or more or less a solution to whatever the problem is. Now, just to give a final answer to the question, how much would you pay? I guess I would pay something like $4. I don't know. It's a round number, less than 4.25. The point is, I shouldn't pay more. If I pay exactly, then after many games, I'll be at 0. So I will offer less and hope that the person is I'm playing with is happy to play many times and happy to and just doesn't know mathematics and happy to play with me many times. Okay, so the main point here is that there is mathematics behind it, expectation, etc. And these are one of the easiest questions. Of course, maybe easy medium, this one at least. Still many people fail, but once again, I don't know, but after school, I'm not sure I will be able to solve it, to be fair. I needed some practice and needed some understanding. But I hope that even though you might not understand all the details, for example, how I got this, I don't know, maybe you're shaky a little bit why it's exactly the case. Like, I multiply here, like, this is probability, this is expectation, this is probability, this is expectation from here. So it might, you might be a little bit shaky about this. But that's one more reason to join the Quanta, right? So we'll be happy to explain and give you many problems to practice. Plus, this is something that you can actually play with other people, right? If the die that you play is fair, then yeah, use math, check it out, try, and yeah. So let's, I think I will not go into more difficult mathematical questions. Of course, there are things with, for example, continuous distributions, expectations for random variables with continuous distributions, Gaussians, central limits theorems, etc. Finally, all of this can be explained to a school pupil. Just one prerequisite for continuous is knowing analysis, but everything with the dice, everything with expectations, etc., even more difficult problems are possible, like something that you can understand. So yeah, just so you know, it's not, as you probably see, believe me or anything, this is not crazy difficult. And once again, just to stress it, these are the questions to get into a good, well-paying company, whatever we talked about before. Something that I needed to go through, actually. I think literally some of these questions. So this is our Facebook group where you can find one more question from one of the interviews. It is here, it's in the last post. It's about 3 coins, and just to read it, if you flip a fur coin 3 times, then getting heads, tails, heads, tails are equal problem. Just in case heads and tails are 2 sides of the coins. In different languages they're called different, but in English it's usually referred to as heads and tails. But interestingly, if you toss them many times, so infinitely many, you're more likely to see one combination than the other one. So the question to you is, why is that and which one? And this is no easy question, to be fair. I mean, I would say it's not super difficult, but it's much harder than this previous one. And if you know how to solve it, you can put the solution in the comments, for example, if you think you know how to solve it. Plus, yeah, you can just check the Facebook group and react to it somehow. That is it for today, I think. I should finally say, I think, that we are planning to do courses where we'll be solving more difficult problems and many more problems like this, and we'll go into more applications, different style of kind of probability statistic exercises, problems. So many more will be shared in those courses. This is tip of the iceberg, but it already can give you a feeling about what to expect, what to know, that it's not all super difficult. At least you understand something. That's already good enough when it comes to getting close to, for example, finding a really well-paid job, or going into some amazing research projects, or having enough knowledge and having flexible enough brain, let's say, to go into some probabilistic or statistical things. Yeah. Thank you for your attention and good luck.